Hello everyone. In this video, I'm going to solve one question, which is about vector spaces. We have two equivalent matrices, A and B, the same size of them. The questions will be about find rank of matrix A, dimension of null space, dimension of column space, dimension of row space, the basis for them, the basis for column space, row space, and null space. So let's get commenced. Uh, okay, let me write our matrices first. So its entries is 1, 2, 3, 3, 3, 6, 9, 9, 4, 6, 3, 0, -1, 0, 6, 9, uh, 2, minus 3, 0, matrix B, the same row entries. In here, it's already changed since we do row operations in matrix B. They are same in one thing that the matrix B is the resultant matrix of matrix A. The matrix A is initial matrix, matrix B is resultant. So, question A, find rank A, dimension of null space, dimension of column space, and dimension of row space. Okay. So dimension of null space means how many free variables we have. For easy computation, for easy understanding, we can use matrix B. We also can use matrix A, but it's not useful since we cannot define whether the columns are pivot or not pivot columns. So let's use matrix B. So we have two free variables in here and in here because there is no pivot position. So it's gonna be x2 and x4. So dimension of null space is gonna be 2. What about dimension of column space? Dimension of column space means how many pivot positions we have. So that's the first, third, second, and the third. x1, x3, and x5. That's gonna be 3. So how we can define rank A and dimensional row space? There is a big relationship between them. I mean the equivalence. I will write two formulas how to define first rank A. So rank A plus dimension of null space equals to the amount of matrix, the columns. Since we have 5 columns, the n is gonna be 5. Dimensional space is 2. So rank A uh, equals to 5 minus 2. Rank A equals to 3. We could also make it more shorter. Rank A equals to dimension of column space. So since we have the amount of pivot positions as 3 pivot positions, so we can also confidently say that rank A is 3. What about dimension of row space? Of course, dimension of row space is also equal to rank A or dimensional column space. So it's gonna be 3. The question B is find the basis for column space, row space, and null space. Let's start with the row space. How we can define the basis for row space? We can use the matrix B for easy understanding, defining. So there is such explanation like the non-zero rows of B of matrix B forms a basis for the row space of matrix A. So we are looking for non-zero rows, which is R1, R2, and R3. So we have 1, 3, 4, minus 1, 2. 1, 3, 4, minus 1, and 2. The next row is 0, 0, 1, minus 1, 1, 0, 0, 1, minus 1, 1. And last row 0, 0, 0, 0, minus 5. What about the column space? There is also a relationship with dimension of column space about pivot positions. Uh, we have to write the pivot columns for our basis of our column space, which is the first column, the third column, and the fifth column. But we have to write in terms of matrix A. So it's going to be 1, 3, 1, 2, 3, 3. So I have to write our parentheses more wider. So 1, 2, 3, 3. 406 40630, and the last one is 2 minus 3 minus 3 0. What about the null space? Among them is the most longest part. So for finding a basis for null space, we have to obtain the reduced echelon form of matrix B. But first of all, we have to remember the matrix equation, like linear combination. But since we have the basis for null space, even the null word itself says that our values are gonna be zeros. So let's write the matrix equation. Bx equals to 0. So it's gonna be a homogeneous matrix. Um, 1, 3, 4, minus 1, 2, 0, 0, 1, minus 1, 1, 0, 0, 0, 0, minus 5, 0, 0, 0, 0, 0, and our zeros as values. So what we're gonna do now, so let's indicate our vector values. Minus 5 x5 equals to 0, so x5 is gonna be 0. X3 plus 6, no, not plus, minus, plus x5 is gonna be 0. Since x5 is 0, we can eliminate this, so x3 equals to x4. What about the first row? X4 plus 3, x2 plus x4, x3 minus x4 plus 2, x5 equals to 0. We can eliminate this, so it's going to be x1 plus 3x2 plus 3x. Um, we have to write our we have to get x1 since it's pivot position. We write our values. We have to find our variables in terms of pivot positions. So that's why I found x5 as pivot. I took x5 because it's pivot position, x3 as pivot position, and x1 as pivot position. So, so it's going to be 4x4 minus x4, 3x4 equals to 0, x1 equals to minus 3x2 minus 3x4, right? And yeah, we got our values, and let's write our vector form. So x is x1, x2, x3, x4, and x5 equals to x1 is minus 3, x2 minus 3, x4. X2 is free variable. What about x3? I guess it was x4. X4 is free variable, so nothing changed, and x5 is 0. So let's write it in the vector equation form. So it's going to be x2 with column with entries minus 3, 1, 0, 0, 0, plus x4 with entries minus 3, uh, 0, 1, 1, 0. Because for x2 in the first row we have minus 3 coefficients. For x4 we have minus 3 again. What about x2? For the second row we have only variable x2, so it's going to be 1 because we also have 1 as the coefficients for any variable, but there is no x4, so that's why we write zeros. So thank you for your attention.